Hi, this is Vitasta Jain, and today I'll be talking about the fatal explosion that happened in the AirGas facility in Cantonment, Florida in August 2016. At 12:10 on August 28, 2016, a nitrous oxide trailer truck exploded at the AirGas facility in Cantonment, Florida. The explosion killed the sole AirGas employee, Jesse Folmar, present at the facility. He died from explosion-related fragmentation and blunt force injuries. The explosion also heavily damaged the facility, halting nitrous oxide manufacturing indefinitely. During the initial loading of a trailer truck, a pump heated the nitrous oxide above its safe operating limits. It is assumed that because of this overheated system, a nitrous oxide decomposition reaction began. Since the decomposition of nitrous oxide generates heat, it is self-sustaining. Due to the force of the explosion and the extent of the damage to the facility, no definitive conclusions were made. However, the most likely scenario was formulated. According to the Center for Chemical Process Safety, a nitrous oxide explosion is most likely when the tank is empty or near empty, for example during the initial transfer of nitrous oxide. According to reports, the tank that initially exploded, trailer 182, had just returned from delivery. It was empty and did not contain a protective inventory of liquid nitrous oxide. AirGas management systems were not sufficient to deal with nitrous oxide as a reactive hazard. An explosion occurred when the loading pump was running dry, since there was not enough liquid level. The sealant at the pump head acted as a contaminant, which enhanced the propagation of the decomposition reaction. Similar incidents have taken place previously, but AirGas still did not have safety management systems to deal with them. Here's a list of events that precipitated the accident. AirGas didn't have safety management systems sufficient to deal with nitrous oxide. Nitrous oxide wasn't identified or treated as a reactive hazard. No inherently safe design features were implemented to prevent such an accident. A lack of automated shutdown procedures led to decomposition propagating and led to Jesse Folmar being on site. Nitrous oxide pumps weren't classified as critical equipment, and proper management of change wasn't done. CSB in their report identified specific design problems. We'll first talk about flame arresters. A filtration strainer packed with steel wool was used instead of a flame arrestor. Manufacturers of the pump, Smith, recommended specialized flame arresters to be used on either side of the pump. It was not followed. AirGas also didn't test the flame arresters for nitrous oxide systems. The steel wool, mesh size, etc. were not standardized, the device wasn't efficient, and wasn't robust. Later, it was found out that the steel wool had already half decomposed prior to the incident, which indicates that AirGas didn't perform prior safety checks. Run-dry safety interlocks are used to automatically shut down to prevent a pump from running low. This one specifically was set for flows less than 15 GPM. What it meant was that during the initial startup, an operator had to manually make sure that the liquid levels reach 15 GPM and then allow the safety interlock to take over. There were no temperature controls, leaving the pump to run regardless of liquid nitrous oxide vaporizing due to heat, causing the pump to run dry eventually, ultimately leading to a decomposition reaction. Pump manufacturers recommended flexible connections between piping and pump. While this was used at the facility, it was not used for the loading and unloading of trucks. Mechanical seal was another problem. Due to the closed coupled pump design, the seal was most likely the heat source to start the explosive reaction. Dry running an unlubricated seal causes it to heat up. This would lead the connecting pipe to heat up. For a 2-inch pipe, 50 degrees Fahrenheit is enough to start a decomposition reaction. In this section, I will be talking about some of the control problems in the facility. Instrumentation to monitor pump performance. Both Cryostar and ACD, the pump manufacturers that AirGas used, recommended instrumentation to monitor pump performance. Lack of this led to no indication of temperature, pressure measurements for pump inlet and outlet, and this left the operator with no data to figure out if the operation was running as intended. For the mechanical seal, AirGas failed to account for a pressure drop due to the packed strainer. This could have led the pump to run dry due to partial vaporization of nitrous oxide, starting the decomposition reaction. Packed strainers could have increased the pressure drop by a factor of 10. For the loading pump system design, the pump manufacturer recommendations were not followed. There was a lack of preventive maintenance programs for the nitrous oxide pumps since they were not cited as critical equipment. There was also a lack of automatic process control for the trailer truck loading. Storage tank levels were also not monitored, no level indicators and no alarms were installed for indicating low levels. There were no safeguards to prevent the operator from aligning an empty tank to the pump. Doing so would have rendered the interlock useless and directly created the conditions for the nitrous oxide decomposition reaction propagating. For the operating procedure, the pump recycle piping was configured for the wrong specifications. The nitrous oxide circulation to the relief valve led to the vapors being generated. A better design would have been to redirect the relief valve to the storage tank with the minimum level of liquid already maintained. In addition to the already cited problems, there were management problems, including maintenance and bad decisions. The loading pump system design. When changing pump manufacturers, management of change wasn't done. AirGas switched over to Cryostar centrifugal pumps for their operations. Upon failure, the company further switched to ACD pumps. No hazard analysis was conducted either time. There was no management of change review done for replacing the pump, leading to specifications of the pump not being met. The new pump needed an additional 2 inches of liquid level to prevent nitrous oxide vapors. The man-down system, which was supposed to monitor operator status, was not functioning during this incident. Management was aware of the issue and didn't timely rectify or change procedure to ensure safety. Here's a list of recommendations that were reiterated from previous incidents that were not implemented by AirGas. Provide 5 feet of liquid above the pump to ensure adequate liquid supply to the pump. Use both a strainer and a metallic flame arrestor on each side of the pump. Install a safety interlock to shut the pump motor off when there is low motor load. Construct piping to circulate liquid back to the storage tank during initial start and cool down of the pump. Here's a list of immediate technical recommendations, some of which are from the safety standard that was developed in part by AirGas, CGA G8.3. Number 1. Designing equipment properly for NO2 use. Number 2. Using strainers of better materials such as high nickel or copper alloys. Number 3. Automatic controls for temperature and shutdown. Number 4. Performing management of change and risk assessment whenever critical equipment is being changed. Number 5. Providing a safety interlock to ensure proper liquid filling and pump cooling before pump can start. Number 6. Preventing pumps from operating if they lose prime. Here's a list of the second layer recommendations for avoiding the hazard. The company should evaluate its safety practices when operating the facility with just one employee. Better safety systems for the employees, including proper operation and upgradation of the man-down system. Because degradation of equipment safety systems may not work. To prevent future contaminants and catalysts in the vessels, evaluating and upgrading equipment is a must. Testing steel wool grade, mesh size, strainer design, all of this needs to be tested and standardized to prevent a nitrous oxide decomposition from propagating next time. The third layer of recommendations for improving the management systems are as follows. There may be opportunities to prevent future nitrous oxide decomposition explosions by applying inherently safer design and hierarchy of controls. Annual safety audits focused on the process safety is recommended. This is to delve into deeper aspects of the site's safety systems. Additional technical staff need to be hired to ensure nitrous oxide processing hazards are appropriately identified, evaluated, managed, and controlled. In conclusion, this was a tragic accident that could have been prevented if proper safety systems were in place and followed. The explosion, due to an uncontrolled nitrous oxide decomposition reaction, was fatal to the operator and was large enough to damage the facility extensively. As a result of the investigation, numerous problems were found and standards updated to prevent such an accident from happening again.